Time to talk about halogens. Halogens are, for our purposes, group 17, the fluorine, chlorine, bromine, iodine, and astatine. We rarely refer to astatine because it's one of the rarest elements in the Earth's crust. So I'm kind of going to ignore it for discussions because it ends up being more of a theoretical than a practical. Okay, things that you already know is they tend to be diatomic. You've already learned that fluorine, chlorine, bromine, iodine, and astatine, when they're alone, are diatomic. You haven't learned astatine because for reasons I just said, so I'm just going to ignore it. Whether or not they are gases, liquids, or solids depends on the particular halogen. So fluorine and chlorine are gases at room temperature. Bromine is a liquid. And iodine is a solid. They tend to be colored things. Fluorine and chlorine are both greenish, yellowish, greenish gases. Bromine is brown, and it's a brown liquid. And iodine is kind of a grayish, metallic-y looking solid. That's most of what you need to know about their physical properties. In terms of their chemical properties, they are extremely reactive. You've already learned how to write reactions involving them. Reactions with group 1 metals. So for example, if I have lithium plus bromine, if I wanted to write this reaction out, lithium's symbol is Li. Group 1 metals are solids at room temperature. It's going to react with bromine, which is diatomic, and liquid at room temperature. When these react, they're going to form lithium bromide. Lithium, as you know, is a +1. Bromine is a -1, so they will join to form LiBr. Ionic compounds at room temperature are solids. Balancing this gives me a 2 and a 2. We are also going to look at single displacement reactions of a halogen reacting with a halide. Now, the order that we have group 17, at the top here is the most reactive. And at the bottom is the least reactive. When we say single displacement reaction, the halogen is capable of displacing a halide, meaning the ion, below it on the chart, on the periodic table. So for example, if I have F2 reacting with NaCl, this reaction will work because fluorine is more reactive than Cl, so F2 can bump out the Cl minus. And in a single displacement reaction, which we learned earlier this year, these would be my products. I would balance it like so. However, if I tried to do this reaction, Br2 plus NaCl, bromine can't bump out chlorine because bromine is less reactive than the chlorine. So here we would get no reaction.